good old days with the Big 105 Retro Lunch. Brought to you by the Canadian Brew House. All the best 80s, 90s, and more. Weekdays at noon on Richard's Best Music. Big.
Morning, Conrad. Good morning, grade 10s. Starting off today with a little bit of a brain teaser. I bumped into my long-lost uncle from Alaska in the street. I'd never met him, seen his picture, or heard him described, yet I recognized him immediately. How? Who's got an idea on this one? Nobody? Okay, so let me give you, oh, Charlie's just joining us, and he usually gets these, so I'm counting on you, Charlie. I bumped into my long-lost uncle from Alaska in the street. I'd never met him, seen his picture, or heard him described, yet I recognized him immediately. How? It's a little bit of a head scratcher. Okay, let me get you thinking in the right direction. This long-lost uncle is my dad's brother. There's a little bit of a hint. No one? Oh, good. We got a taker. Charlie, what do you think?
If he recognized him, then he must look similar to his dad.
Yes, in fact, it's his identical twin. Good work. All right, I knew I could count on you, Charlie. All right, another little activity for you today. We're going to do a little bit of math, just quick calculation that's going to tell you some really deep things about yourself, your innermost thoughts, really. So follow along with these steps. Start by picking a number from, actually, it should be your favorite number from 1 to 9. multiply this number by 3. Then add 3. Then multiply by 3 again. Now you'll either have a 2-digit or a 3-digit number. Add the digits together. And then remember the number you get. Okay, and we had some people just kind of logging in here, so I'm going to go through it again for anybody who missed it. Pick your favorite number from 1 to 9. Multiply this number by 3. Then add 3. Then multiply by 3 again. So right now you'll have either a 2-digit or a 3-digit number. Add the digits together. Now this final answer, this number is actually going to show you who you believe the greatest person in the world is. Okay, so if you got 1, it's Albert Einstein. If you got 2, it's Nelson Mandela. If you got 3, it's Margaret Atwood. If you got 4, it's your mom. If you got 5, it's Bill Gates. If you got 6, it's Mahatma Gandhi. If you got 7, it's your dad. If you got 8, it's your best friend. And if you got 9, it's me. Thumbs up if you got 9, everybody. Tricked you. Cool, hey? Now what you need to do is you got to play this with your parents and tell them their number is going to represent who their favorite child is, or something like that. It works out every single time, which is kind of mathematically cool. All right, let's see how we're doing here, guys. We are going to be voting today on whether to do our lesson 1 quiz today or tomorrow. But we will, of course, start by finishing up lesson 1 before we do a vote. Let's take a look at our worksheet, everybody. We have 3 pages of practice, pretty quick practice, really. The 3 pages makes it sound like a lot. So page 1 is all about deciding, is this relation a function or not a function? Now, right now we are looking at, these are called mapping diagrams or arrow diagrams. They're really just another way of showing a relation. Remember that your first column or oval is always your X. Your second one is always Y. And also remember, X is always independent. And we also learned yesterday another word that we sometimes use for X is the input value. Okay, and then Y, that is the dependent variable. So when we make our graph, the variable we put on the y-axis always depends on the one that is on the x. And this is also sometimes called output. Now, mapping diagrams can be a little confusing. So sometimes it's helpful if you just write out the ordered pairs or the table of values even. So the ordered pairs here would be 7, 7, 8, 4, 9, 9, To decide if it's a function, we're going to look at all of the x coordinates to see if any of them are repeated. And since none of them are repeated, that means that it is a function. Now, if you didn't want to write out the numbers in ordered pairs, you could also look at, for example, here in number 4, we see that this x value is matched up with the 6 and the 7. If I wrote it in ordered pairs, that's what would happen. We'd have 2 points that have the same x. And so it is not a function. All right, let me scroll through here and see if there's any that you guys have questions about. So any questions from the first page? Okay, on the second page, we bring in the other concepts we talked about yesterday, which was domain and range. Now, we'll go a little slower here so you can check all of your work. One of the things I want you to remember is when you list your domain and your range, notice that the numbers always go from smallest to largest. Notice we're always using those curly brackets. Okay, we said yesterday that's not just to be fancy. That is the proper symbols or proper mathematical notation that we would use. Also notice that we never repeat numbers. Now let me give you an example of that. I have to find the right one here. Here's one. Let's look at number 3, you guys. Not sure, it might have happened sooner, maybe I just missed it, but notice here in number 3 that 5 is a y coordinate 2 different points. So when I list my range, I'm listing all of the y coordinates. But notice the 5 is only in there once. So domain and range, we always go from smallest to biggest, and we never ever repeat numbers. Okay, so we'll just kind of leave this up here while you are checking. Do we see any questions so far on these ones, you guys? Here's a bit more. So really, so far, when we think about domain and range here, pretty easy, right? Just listing off numbers. Couple picky rules though, smallest to biggest, never repeat the numbers, always use the curly brackets. But otherwise, not too tough. Today, when we finish off our examples in lesson 1, we'll see, well, domain and range can get a little tougher than what we see right here. What it depends on really is how is the relation given to us. So this page right here is probably the easiest one to do domain and range because we actually have a list of all of the x and y coordinates, so pretty easy to do. Now imagine, let's go to page 3. Imagine giving the domain and range of these functions. So this is just another way that a relation can be given to us. So a relation can be given to us by graph. Now, if we had to do domain and range, list all of the x coordinates and all of the y coordinates from the graph, it is going to get a little bit trickier. But this page was just about, is it a function or is it not a function? So guys, this is where the vertical line test came in. Now, you can just do your vertical line by holding a straight edge up to the graph. Since I can't really show you my straight edge, I'm going to draw some vertical lines. I could try drawing a vertical line right here, and it would only touch once. I could try it here, and it only touches the relation once. No matter where I draw it, it will only ever touch this one once. So it is a function. But if, let's say number 4, it is possible to draw a vertical line through the graph that touches more than once, then this is not a function. It goes back to our definition though. If you think about these points, that point right there, the x-coordinate would be 3. Y-coordinate, I'm going to guess maybe something around like a 1.2 or something around there. This point right here, x-coordinate of 3, y-coordinate of about -1.2. So that vertical line test, what it does is it's testing to see, are any of the x-coordinates the same? Grade 10, do we have any questions about the vertical line test? All right, we're going to get back to where we left off on our lesson 1 examples, everybody. All right, so we're going to start doing domain and range from a graph rather than a list of ordered pairs. This is the stuff that I said it starts to get a little bit tricky. The very first example, though, is not really any different than having a list of ordered pairs. In fact, if I wanted to, I could just look at the graph and make a list. By the way, guys, my graph looks a little bit off. Those points were supposed to be right on the corners, right on the coordinates, so that we wouldn't have to guess them. But what I want you to see is that this first point here in blue, it would have an x-coordinate of whatever that number is right there. Sorry, they didn't line up very well. It was supposed to be a 1. Now this green point, the x-coordinate would be different than the blue one. It would line up in a different spot on the x-axis. And same with this red point, lining up just before the 3, like maybe a 2.9 or something. And the black one lining up maybe at about a 3.9 or a 4. So first of all, what I can see is that these are this is definitely a function. None of the x-coordinates are the same. Now, when we go to list our domain and range, oh, there goes my points. Oh, I can fix them now, actually. Hang on a sec, guys. Let me line up my board here so I can actually fix them. So on this one, when we go to give all of the x-coordinates and all of the y-coordinates, I could make my own list of ordered pairs. But it seems like it would be an extra step. So let's get our points back on here again. The quicker way is going to be, rather than making a list of ordered pairs, the quicker way is going to be just to see where do they line up on the x-axis. So let's look first at the x's, because remember, domain is the list of x-coordinates, and range is the list of y-coordinates. And you know, yesterday we talked about how things tend to be in alphabetical order. It's the same thing with domain and range. So if you're doing your work at some point and it says find domain and range and you're like, oh, which one is X, which one is Y? Well, the D and the R in alphabetical order would line up with the X and Y alphabetical order. So let's look at our X coordinates. Where do these points line up on the X axis? Well, curly bracket, the X coordinates on this graph would be 1, 2, 3, and 4. And the Y axis, they line up at these points. 1, 2 at the 3, 4, 5, and 6. So still pretty easy, like the ones we did on our sheet. But this next one, there's a lot of X coordinates on here, more than you might even realize, because this point right here has an X coordinate of about 1.9. And this one right here has an X coordinate of about 3.2. And we got a point in here, probably about 2.875. And what about this guy right here? 2.1894. So what I'm trying to show you guys here is that when you have a solid line, there are so many points making this line that we can't possibly name all of them. So the list that we made up here for our first one, just a list of numbers, is not going to work. So it says, think in terms of endpoints when the line or curve is solid. So a line or a curve means a whole bunch of points that are connected. Ask yourself these questions. What is the smallest X value and the largest X value? So let's look at our X's to start. Remember, X is the domain. So once again, I want to look at where, let's see if I can fix this up. I want to look again at where does this relation line up on the X axis, just like I did in the first one. Well, the lowest X value is going to be 1. The highest X value is 4. And you know what? All the points in between would also be on that line. So we need a way to say, oh, it's just all the numbers from 1 to 4. And we're not going to try to list them because there's decimal points in there. So I cannot just go 1, 2, 3, 4, because there's numbers in between the 1 and 2, and there's numbers in between the 3 and the 4, and so forth. So we have to learn some new notation. And here it goes. So I'm going to write it down, and then I'm going to explain to you what everything means. So curly bracket again. I know you just feel like, what the heck is that? Is this suddenly a class on the Greek language, right? Feels very weird to see all these symbols. So let me show you what it all means. Sorry, I wanted to try the magic pen there. Oh, yes, it is what I wanted. All right, so we start off with this part right here, which means, oh, wow. Let's get rid of that. So we want this part right here, which is x such that. So every time we're giving the domain, we'll start with that. So the domain is x such that, and then this part right here, what that means, it's kind of almost like it's in two pieces. It's saying the x coordinates on the graph are bigger than or equal to 1, but less than or equal to 4. So there's kind of two statements there. So that very first statement is just saying the x coordinates, see how the x is at the bigger part of the sign? Meaning the x coordinates are bigger than or equal to 1. Then we have this other statement here, like a whole different statement saying the x's are smaller than or equal to 4. Because x is at the small part of the inequality sign, the x is smaller than 4. So if we put it all together, in math it reads this way: 1 is less than or equal to x, which is less than or equal to 4. In everyday language, it means x includes everything from 1 to 4. That's really what it means. Now, when we make that statement, guys, that statement is really the meat and potatoes of this whole thing. We always put the smallest x coordinate first and the biggest one at the end. And as long as you always do that in that order, then you never have to change what's going on in that green circle. The signs, those inequality signs, will always be pointing in the same direction, as long as you always have the smallest and the biggest. And it's exactly how we think it should be, right? Small on the left, big on the right. Okay, so that's kind of the meat and potatoes part. Now this last bit, right in here, it's telling us what kind of numbers the x coordinates are. So it's saying that x is an element of real numbers. And what that means is that it includes, the x coordinates include all the numbers from 1 to 4. So it includes the fractions, it includes the decimals, it includes the square roots, it includes every single number from 1 to 4. So every time we have a solid line, a whole bunch of connected points, we will always have this. We will always have this. Those two parts are going to stay the same every time. The part that's going to change every time is going to be, where did it start and where did it end? So really, once you get the hang of, this notation, the only thing you're really looking at is where did it start and where did it end. We're going to do the same thing now with range. I'm just going to need a little more room probably. Let's just do our range down here. So always think about where does it start and where does it stop. So now we're looking at the y-axis. Where does this line up on the y-axis? Well, the lowest point is right here at the 3. The highest point is at the 6. And it's a solid line, so it includes all the numbers in between the 3 and the 6. So here's the part that's always going to be the same for a solid line. We'll always have the curly bracket, and then we'll say y such that. So that's the same every time. And because it's a solid line, the y coordinates on this graph are every kind of number. So y is an element of real numbers. The other part that's going to be the same is this part. And the only part that we're changing each time is really what was the lowest point and what was the highest point. So I would have the lowest y value is 3, the highest is 6, and the symbols all together mean the range is made up of the y coordinates, which include all real numbers from 3 to 6. Okay, so it looks crazy, but when you really break it down, it's not too bad. It's just about where did it start and where did it stop. Okay, now guys, we're gonna actually go to this one next. So I want everybody looking at this one right here. So this is the one we're gonna take a look at. We're interested again in the starting and the stopping point. So let's start with the x-axis. So there's a few reminders here, things we should think about. Does the graph have a starting point? Does it have an ending point? And it definitely does. That point right there means that that's where it starts, that's where it stops. Compare that to the one above here, you guys, that has arrows on it. That one does not have a starting or a stopping point. So we'll need a different method for giving our domain and range. All right, so let's try our domain. So find the point on the left and the point on the right. And because this is a solid line, it includes all the numbers in between. The decimals, the fractions, the square roots, all of them. So this is going from -4 to +4. So now we just need to have the right symbols to say the x coordinates include all the numbers from -4 to +4. So I'm going to start with the stuff that is always the same. Domain is x such that I know I'm going to have these symbols. So guys, that's kind of like my little template. I start with that, and all I have to fill in is my starting point and my stopping point. So it goes from -4 to +4. Now I want you to try the same thing for the range. So the lowest point on this graph is right here at the 2. The highest point is up here. And we want our range to say it includes all the points in between the bottom and the top. Everybody give that a try with the proper notation. And by the way, this notation we're using, it's called set builder notation. So you might have the odd question where it will say, use set builder notation to give the domain. Okay, and so our range. Range is y such that goes up to the 6. 2 is less than or equal to y, which is less than or equal to 6, and y is an element of real numbers. Now, quite often when we're in class here, people will say, do I have to do that fancy R? And you do, because you know what? A regular R is quite often used for range. And this kind of fancy R is used for real numbers. So there is a difference there. So you do have to try to do that kind of fancy looking R. Now we're going to go through, I want to give you another one to try. I want to pick out the ones that have end points. Because if they have a start and an end, not this one, It's hard to tell, guys, but this has arrows on it. So we're going to come back to that one. Oh, here's one. So please give this first one a try, just to make sure we've got it. All right, so I want you to check your work with mine. Domain is X, such that -7 is less than or equal to X, which is less than or equal to 7, and X is an element of real numbers. Okay, and our range, Y, such that -3 is less than or equal to Y, which is less than or equal to 5, and Y is an element of real numbers. So this is a really good one, I think, for me, just to kind of show you what exactly does domain and range do. When you're given domain and range of a graph, you might not know at all what kind of shape the graph makes. You might not know, is it a line? Is it a circle? Is it a curvy kind of graph? But what you do know is you know the position of the graph. So here's what the domain and range tell me. It tells me that kind of like, oh, that green box, the position of that green box, that's where this relation lives. So it's just kind of explaining, describing the position of the graph. So go ahead and try the second one on this page, everybody. I know it's a circle and it's kind of weird, but you still follow the exact same process. Find where does it start on the left? Where does it stop on the right? You don't really care what's going on in between those points, but just we want to say where's the left, where's the right, where's the bottom, where's the top. It's like we're giving the borders, the position of this circle on the graph. Okay, and check your work over here, guys. Any questions about that one? All right, so we've got this one that we need to, this other situation where, well, what if there are no endpoints? You know, we said when we're giving domain and range, we're always going to have the smallest number first, the biggest number second. So talking about You know, where's the left side of the graph? Where's the right side of the graph? Well, what if there isn't a point at the left where it ends or a point at the right? So kind of these questions we go through each time. Can you determine the smallest x value? Now this arrow that's on here, what it means is that this graph really does keep going forever and ever and ever in that direction and also in that direction. So because it just keeps going and keeps going, it's impossible to say, you know, find a spot on the left-hand side and say that's where it starts. So it's a very abstract idea to think it actually never has a starting point over there. So no, we cannot determine the smallest x or the largest x. So x's have no endpoints. So when it comes to domain, when there is no endpoint, there's no start, there's no end, all we have to do is say x is an element of real numbers. And that's it. It's kind of easy when there are no endpoints. And what we're just saying there is the x coordinates include every single number. In math, we say includes all real numbers, but in our own language, we'd say every single number would be an x coordinate. So if we were looking at, let's say, an x coordinate of 8, oh, that might be off the chart here. Let's say we're looking at an x coordinate of 5. 1, 2, 3, 4, 5. There's a point right there that has an x coordinate of 5. How about an x coordinate of -7? That point right there would have an x coordinate of -7. Now, obviously, I can't make this graph big enough, but if we said, how about an x coordinate of 1 million? Yep, it would be on this graph. Okay, let's switch our thinking over to the y's now. And one of the things too, in case it hasn't really sunk in yet, when we're talking about domain and x values, we're really talking about the left to the right. So we're describing the position of the graph from the left to the right. And when we switch to think about the y coordinates, we are now talking about describing where's the lowest point and where's the highest point. So we're talking about the bottom to the top. So we're describing the lowest and the highest point on the graph. So again, our little questions we ask, can you determine the smallest y value? Well, we can, right here. The smallest y value is 2. Can we determine the largest y value? So trying to find the ceiling, like where does this stop? But those arrows say it just keeps going forever, higher and higher and higher. So nope, we cannot find the highest point. So we want to use symbols that will say the y coordinates include everything from 2 and higher. Sorry, I'm just looking ahead to pick some questions out for us. All right, so our range. We're going to say it's y such that y is greater than or equal to 2, and y is an element of real numbers. So it looks a lot like it did before when we had 2 endpoints. except we only have one. Now, when you make this statement, it should always be pretty much in this position. Your y should always be named first. The sign that you have, it could change. It depends now on whether or not we're talking about from the bottom up or from the top down. So we will have to understand our inequality signs. So just to make sure we understand them, this is telling us that the y coordinates are bigger or equal to 2. Okay, let me give you another example. If I make this statement, y is less than or equal to 5. So notice that y, when I look at this inequality sign, I look at it as it has a small part. So on the left is the small part of the sign, and on the right is the big part of the sign. Now y is at the small part of the sign, and 5 is at the big part of the sign. So this would be saying that the y coordinates are smaller or equal to 5. So these ones where you only have one start or end point, you've got to know those inequality signs. They will not be the same every time. All right, let's take a look at another one like this. Okay, so find this one, you guys. It's not super obvious because they're so small, but this has arrows on it. So ask yourself, let's look at x's first. So look at the left-hand side of the graph. Is there a point that you could say that is the smallest x value? No, it's going to keep getting wider and wider and wider. So it's never going to reach a point where it actually ends. And same thing on the right-hand side, right? Domain is describing the graph from the left to the right. Well, it just keeps going forever from the left to the right. So for domain x, such that x is an element of real numbers. So remember, that's what we see when there's no beginning, no ending. It just goes on forever and ever and ever. Now, range is describing the top or the bottom. Well, it does have a top. The top of this graph is at the -2. So guys, I want you to try to get the right symbol here. So y such that, I'm going to have y, I'm going to have -2. And right in here, I want you to get the proper inequality sign. You need the sign that is saying that the y coordinates are everything from -2 and lower, because that's where it lines up with the y-axis, right? It starts at the -2 here, and it just keeps getting lower and lower. So we need to put our inequality sign like this. The small part of the sign to the y, because the y coordinates on this graph are smaller or equal to -2. All right, so let's give you guys one to try completely on your own here. These are arrows. All right, give it a try. People. right, so let's look at my domain. My domain is saying what I've shown here in red. So what I'm showing right there with the red is that the graph, the farthest point on the left is -2, but that it keeps on going forever to the right. So the x-coordinates include everything from -2 and bigger. And then if we look at where does this line up with the y-axis? Well, it's a little bit hard to tell exactly, but guys, this is getting wider and wider and wider as it goes. So it's going to go forever. There's no top and there's no bottom. So y coordinates would be all real numbers. Now, there's one other type we need to take a look at. It's not a super common one, but what this graph is showing, this open dot, rather than the closed dot that we've seen, means that that point itself is not actually included in the graph. So this is -7. And this is +3. So here, this graph for x-coordinates, it includes everything in between -7 and 3, but it does not include the points -7 and 3. So can you guys sort of think about what is going to change in our symbols? So x such that -7 is less than x, which is less, oh no, that's right, 3, and x is an element of real numbers. So this time we're saying the x-coordinates include all the real numbers from -7 to 3, but not including -7 and 3. Please go ahead and try the same thing for your range. Everybody looking at the top and the bottom of the graph. Okay, and so our range is y such that -5 is less than y, which is less than 2, and y is an element of real numbers. Now, in a way, we're kind of lucky that this is an online unit because all of this notation is very, very picky stuff. So it'll be nice that most of your questions like this will be multiple choice. You won't actually have to write down or type out all of this notation. Now, guys, I want you to try our last example, noticing that the point here on the right is closed and the point on the left is open. See if you can figure out your inequality signs for this one. Now you might have noticed it said here, do you remember the open dot, closed dot from Math 9? So back in Math 9, you did inequalities, and you had to put the inequality on a number line. So you guys might remember, we looked at this red at my domain here. You might remember doing graphs where you'd have an open dot and a closed dot. This is kind of the next step from there. And our blue, our range here, we'd say, oh, it's closed dot here, it's open dot there. So it is kind of an extension from grade 9, but I know that's a long time ago. So let's try your domain. X such that, now if you want to start just with your point on the left and your point on the right and your X in the middle. And then just take a moment to think about your signs. The one thing we said will always be true is they'll always be pointing in the same direction. As long as you've always have the left here and the right here. So that's one thing for sure. Those inequality signs will always point the same way when there is a start and a stop point. And then the ones where we put the equal to sign are just the ones where it's a closed dot. So I would need the equal to right there. So I'm saying the X coordinates have everything from -5 to 7, including 7, but not including -5. Now, after seeing that one, see if there's anything you want to switch on your range. Do you want to change anything about your range? So we do have a starting and a stopping point here. So remember, I'll always put the bottom first. The top will always come next. The inequality signs will always point the same way as long as I always start with the bottom, then the top. And now all I have to do is figure out, are there going to be some equal signs? So closed dots mean we need an equal sign. So my -3 needs to have the equal sign. All right, so this whole Greek to me as we started out, hopefully is cleared up a little bit, guys. Any questions there? All right, so I don't think we're going to do our vote for the quiz because I actually thought we were going to have more time. So our quiz will be tomorrow. What we'll do is we're going to do our practice work today to get a little more practice on domain and range. So guys, what you're finishing up today is back to lesson 1 worksheet, this time working on page 4 and 5. So that's your practice work today. And then tomorrow we will do our quiz on lesson 1. And then we will do a little bit of a flashback Friday, throwback Thursday. So dig those sheets out and I will try to post them today as well. Any questions before we dismiss? Now remember, if you do have questions or you need help, please stick around for the last 20 minutes or few minutes of class. Otherwise, guys, stay strong, be kind, stay safe. See you tomorrow. Hey, Jet, how have you been doing, dude? You there, Jack?